Hello and welcome to another video. In this video we're going to continue the on-site interview loop. So I think we did Amazon last. So we'll do the Microsoft one. I think we have 3 left. I'm going to do the same thing, focus on clean code, dry running, and not have mistakes. So let's see how we do. Alright. So given a matrix, if it's 0, set the row and the column to 0 in place. Interesting. Okay. All right. Okay. So I think what we need to do here is, if we have a 0, like let's pretend this is separate and this inner thing is the thing we care about. So in this inner thing, if anything's a 0, we can set that corresponding row and column to 0. So for example here, if this is 0, we'll set this to 0 and this to 0, like here. And then after we're done with this whole thing, whatever's 0, we'll 0 out that whole row and column. Now the other thing we need to do is we actually need to check, is there a 0 in the row and the column? So we could have variables there. So we're going to check this top row for a 0, check this for a 0, have those in like a boolean, and then do the inner part. And then for the inner part, then we'll set these to 0s. Yeah, sounds good. All right. All right, so we'll do like top or row 0 or something. We'll make it or top 0 or whatever, top 0. Make it false. And left is 0, make it false. So essentially these two. Now we have to go through the top row and the left. So top row is going to be if matrix 0 and the column 0, then top 0 is true. Okay, same thing for the column. Row 0, left. All right, now we can go through the rest of the matrix. So if matrix row column is 0, then we're going to set the row and the column to 0. So matrix row 0 is 0, and matrix column 0 is 0. Okay, done there. Now we need to go through the matrix again, this inner part, and if the row is 0, then we're going to 0 out the whole row, and if the column is 0, we'll 0 out the whole column. So let's do that. All right, so if matrix row 0 is 0, so if this row is 0, then we'll just do that. So if row 0 or 0 column. So essentially we're going to go through this guy. This will be 0, this will be 0. So when we come here, this will be 0. Come here, this will be 0 because this is 0. This will be 0 and this won't be. All right, now we gotta, if the top 0 is true, we gotta 0 out the top row. So if top 0, then we'll 0 out the top row, which is this one. Right. Okay. And the same thing for the left. So if left 0, we'll 0 out the column. Okay. All right. Don't think we need to do a dry run. We'll see how this goes. Yeah, it's kind of hard to dry run this thing and you have a lot of code. Let's see. Okay, we got a problem. So let's. So what's the problem? I guess. Okay. So we never zeroed out the row. Looks like we never zeroed out this top row, and we never even put a 0 here. So let's debug. If matrix RC is 0, Oh, right, this is backwards. Okay, so if the row is 0, we need to zero out the row. So this is going to be the top row, so this is 0 and column. And to zero out the column, we need to do the row. I think like this is what we need. Let's give that a go. All right. Okay, so what did we do that was problematic? So we zeroed this out. Yes. So let's just print the matrix in between these stages, and then we can get, we can basically know what we did wrong. So print the matrix here. Yeah, it's kind of hard to like dry run, so. Okay, so here's our matrix after the first section. Okay, so yeah, so this is what we got. So this is fine. This is fine, and then the bottom row didn't. Okay, so that's good. So this part's correct. Now let's focus on this section. So if, oh, this is definitely wrong, right? No, it's not. If matrix, okay, so we need to do if the top row is 0, which is 0 column. Oh, we didn't write it as 0. All right, how about now? It's still not right, okay. So basically, if the top row is 0, which is this. Yeah, we shouldn't, yeah, I don't know why this is here. Okay, too many mistakes. All right, now. All right, there we go. Okay, let's go with it. Cool. Okay, implement a2y that converts a string to an integer. White space ignore plus determine the sign by checking if the next character is minus or plus. Okay. Read the integer by skipping leading zeros until we get an integer. Okay. Rounding. If the integer is outside of the range, then round. Okay. Alright, so there's just 42, easy. So negative, we'll just make it, okay, so negative has to be in the beginning or the end, I guess. So first we can do trim, I believe. Let's look up Python trim. Trim. Strip something. Trimmed string. Yeah, that's what we need. So I guess it's strim or strip. Yeah, okay. All right. Okay. Then check the sign. Okay. White space, negative. Okay. No characters are red. Okay. What do we convert letters to? Okay, so as soon as we get to a non-digit, we're done. But we can accept the decimal, I think, right? Let's see. No characters are red because there's no, okay, 0. Okay, I see. So, okay, so we have to do this order. So number 1 is done. Okay, so if, we'll just check for the first character now. So if s and s0 in plus minus. Okay, so if s0 equals plus, we'll do like positive is true, or yeah, we'll just do positive true. Okay, so all we need to do is just if it's 0, then we will make it negative. All right. So that part's done, and then we also need to go s equals s1. All right. So we got rid of that conversion. So we read until we get a non-digit. Okay, and there's no decimal, right? Yeah, no decimal. Okay. So we read until we get a non-digit. Okay, so just go with like num. Okay, while or for I in the range plus, or just for character really. If, let's look up is digit. Is digit. Okay, so string dot is digit. Okay. This is false. We're gonna break. Otherwise, we're just gonna keep reading it in. And you could, no, because this can be a long character, right? Words. Yeah, it could be 200 characters, so you're just gonna want to append, okay. All right, so we keep appending. Then we convert to an integer. And I guess in Python this is easier, so that's kind of nice. So then we go num equals int num times, or I guess like, yeah, so then we have to convert it. So times 1 if positive, else -1. All right, now we just have to round it. So if num is less than -2 to the 31, num equals -2 to the 31. So we'll just do it this way. Pow, -2, 31. Num equals, all right. Okay. If num is greater than 2 to the 31, 1. Num equals pow. 31. Yeah. So in other languages, I think you might get like overflow, so it's gonna get complicated. Python, I guess it's easier. All right, then we just return num. So let's just think about what would happen here in these cases. Okay, so 42. This is not gonna happen. Oh, so it'll be positive. Then we're just gonna take every character and return, so we'll just get 42. All right. Oh yeah, we have to join the num right here. All right. Next, negative, so we'll have the negative 0, 42. So we'll just get 0, 42, convert, that'll be 42, -42. All right. Here, we're gonna get this number, okay. Here, we're gonna get 0. And then that's it, so we'll just return 0. Yeah, I think we're good. Let's see if we missed anything. So I think strip does, or maybe we have to do s equals s strip. Let's see. So that just might be a Python thing. Don't use this very often, so let's find out. Yeah, I think we need s. All right. I think we're good in that case. Words. Okay, so this one we didn't get. So if num is empty, we just return what? 0? I guess 0, right? Yeah, we'll do that. So if not num, return 0. There are a lot of like really random edge cases here though. So okay, cool. Return the number of battleships. Huh? Main shape. Where each cell is a battleship or empty. Return the number of battleships. Horizontally or vertically. Okay, interesting. Oh, I see. So battleships are in a row. Okay. You can only be placed horizontally, vertically. They can be made shape 1 by x. At least one horizontal or vertical cell. There are no adjacent battleships. All right, well, if there's no adjacent, that makes things easier. All right. Yeah, if there's no adjacent, like if we can't have like XXXX and then down here, then it's easy. So anytime we get to a battleship, we just need to check. I'm trying to think. Can we just check let always right or down? Is there any case where that's not the case? Like if we have some matrix here. Something like this. Okay, so if we're just going right and down, is there ever a case where our thing is not like that? I think not, right? Yeah, I think we can just check right or down. Okay, cool. All right, so essentially every time we hit a cell, we're just gonna check, do we have to go right or do we have to go down? And we can either not go anywhere or one of those, and it can't be both. And then we'll just mark it all visited. Can we do it in one pass using O1 extra memory and without modifying the values? Okay. Do I want to do that here though as well? Probably not. Yeah, without modifying the board, this is a little bit tricky. If we make sure like yeah, I'm not going to do that one just because there's 4 questions and I have to think about it, I guess. We'll just do the normal thing with a visited set. And then maybe look into the other solution later. So all right, so if board, yeah, so I guess we'll just mark everything visited always, right? And if we were there already, or I guess no, we can just mark it visited if it's a ship. So if it's an X, we'll mark it visited, and we'll mark all X's visited, and then when we get to the same X again, we'll continue. So if board RC is an X, it's an X, right? Yeah. And C not visited. Or I guess we can do it the other way. So if it's not X or RC in visited, we'll continue. So that way, yeah, I think this is fine, right? If it's not an X, we don't care. If it's an X and it's visited, we don't care. Okay. So now we have to check right first. So if row or column is less than this and board R C plus 1 is also an X, then we'll just keep going right until we run out of space. Yes. I mean, we can even do a while here, honestly. Yeah, so we can make some variables here. So we'll go like row call equals RC. So while column is this, row call. Okay. So essentially we'll just mark the whole thing visited. Okay. And same for the other. Row is less than rows minus 1 and board row C is X. Or sorry, yeah, we need to actually increment, right? Yeah, we need to increment. So if board row plus 1, okay. Okay. Alright, let's double check. So if we get to, so this is an X and it's not in visited. Oh, we need to add the cell to visited as well. Yeah. So yeah, maybe the O of 1 space would be something like we know for sure if we're here, we're not going to go here again, but we might go to later cells, which is problematic, and then we'll mark them again. Oh, I think I get the O of 1. Do we want to try it? Okay. Let's go for it. So I think the O of 1 is, if it's an x and there's an x above or to the left, we'll just ignore it. So the only x's we'll take are x's that are the top left x, basically. Yeah, let's go for it. I think that's correct. So if board x is this, if row is less than rows, and board row plus 1 column is x. Actually, no, we want the other way. Yeah. So this is fine. If row is greater than 0 and board row minus 1 column is x. Continue. So basically this is saying if there's a row above it that's an x, we'll ignore, and if there's something to the right, we'll ignore. So that way we only keep the top left. If column is greater than 0 and board column minus 1 is an x, this needs to be an x. Continue as well. Now we can go. I think that's the optimal. All right, let's see. 2. Nice. Cool. Okay, given a string and a pattern, implement a wildcard. For question mark and wildcard. Question mark can match anything. Wildcard can match a sequence. This has to be low constraints, right? Yeah. All right. Sounds like DP, like just right away thinking DP. All right. So wildcard can match a sequence. So how do we? Okay, I think I'm getting it. So the things we need to keep track, well, how long is this? S&P is 2000. Yeah, so I think we can do an S by PDP, and then I guess we can think of the states. So we can write this down. So we can essentially have like the S index, the P index, and then what thing can we do? So if P is not a wildcard, that's easy. So I guess let's just do like base case, recursive, and all that like I do in my other videos. Base case is S is out of bounds. Then, like if we're done with S, then P has to be out of bounds as well. Or if P is a wildcard, we can, like it has to be out of bounds or all wildcards basically. Okay. Yeah, so if this is the case, then this is like 1, anything else is 0, essentially. Like if P is out of bounds before S is out of bounds, or any of that. So like, yeah, so like P is out of bounds, S is not, 0, and anything else basically. Okay, now recursive. So recursive, so if P is not a wildcard, then chars have to match, that's easy. Okay, P is a question mark. Then we just go forward by 1 in both because it doesn't matter what the character is. So just do dp of s plus 1, p plus 1. This is a sequence. So star, it can literally be anything. So basically in star we have an option of moving s plus 1 or just ignoring, like, because it can be any sequence of any length, we basically do dp of s plus 1 and p stays the same, or we do s stays the same and p is plus 1, and we just keep doing that. I think that's it. Yeah, I think this is like an easier version of like the regex matcher or something. All right, so we'll go with this, and I think that should be, let's do top down, easier. So we'll go ij. So if I equals length s, if p equals length s, return, or length p, return true. If p j, or I guess this is j, if j equals wildcard, then we can just do return dp of I j plus 1. And if it's not a wildcard, then we just return false, because everything else is false. Okay. Now if p equals length, or if j equals length p, and s is not done, then this is just always false. All right, now we do the recursive. So if pj is not a wildcard, so I guess let's just go for not in these. Then if si equals pj, or I guess just we can just do a return here. So return, so these have to be equal, and dp of I plus 1, j plus 1 has to be true. All right. If pj is this guy, return dp of s plus 1. P plus 1 we don't have to check because it's just a question mark. Otherwise, we do return. So if it's a star, we do dp of s plus 1 p, or dp of s p plus 1. And then that way the star can keep going, or it can stop anywhere. All right, now we go return dp 0, 0. Okay, let's try this. Cool. Can you concatenate string, not into string? What are we returning? I guess. Return dps plus 1. Can only concatenate. Oh, right. This is not p. This is like dyn j. Yeah. J, I, j. All right. Nice. Okay, so I guess let's go over how hard this was and which ones have I done. So we got 28 minutes, not too bad. Don't think we missed, I guess I'll go over if we missed anything crazy. Okay, so this one I definitely did before, but it's not a hard question. Like, it's fair medium. Even if you haven't seen it before, easily solvable, as long as you realize the trick of setting the row and the column to zeros and making sure they're 0 beforehand so they don't like get overridden. This one, I don't know if I've done it before. Maybe I have, but there's a lot of edge cases, but also in Python this is really easy. Or like way easier, right? Because if you get overflows in other languages, it's going to be a lot trickier. Maybe not. Maybe that's not that bad. But yeah. Yeah, I mean, maybe you can just detect for overflow. I'd have to check there. Like, how do you check for overflow easily? And then it's not that bad. So this one's fair medium, I guess. This one, the visited set solution seems really easy. The O of 1 is a harder medium, but not too bad. I haven't done this one before. So yeah, I guess, I don't remember if I did this one, maybe not. This one definitely not. And this one, I feel like no, or I don't remember. But for a hard DP, is it really hard? Not really. Yeah. But in any case, I guess we got 4 questions, 1 hard, 28 minutes. Pretty good, I'd say. And yeah, I don't think we missed anything major. Yeah, maybe in this A2I we missed some stuff, but everything else, I feel like I covered all the, like I didn't miss any crazy edge case. It was all just like small errors and stuff. So pretty happy with this one, I think. And then yeah, I think there's like, how many left? Like 2 or something. So this one, so 2 left, and then probably gonna go back and do system design or front end or something. We'll see, whatever. Just kind of trying to do different things so it's not boring. And yeah, if you guys have like a preference for what type of video is good or whatever, let me know as well. So yeah, thanks for watching.